Okay, I'm going to go fairly quickly through this example. So actually just sit back and watch closely and enjoy. Don't try to copy everything down. What I want to go over in this example is there is more than one way to attack many problems, right? So if we were to look at this example, it kind of fits what we just did, where this is an even power of the sign, and it would be cosine to the 0. So we could use the method that we just learned, okay? So one way to attack this problem would be to treat this as a trig integral. Okay, so if we were to do this as a trig integral, we would see, we should probably substitute for sine squared of x, rewrite that as 1 minus the cosine of 2x over 2. And therefore, I'm just going to go quickly with this. This will equal 1/4 the integral of, we're going to, actually, we don't have to, we're not squaring, so that's 1/2 the integral of 1 minus cosine of 2x with respect to x. And so we end up with 1/2. When you take the antiderivative of this, do it this way this time, you'll have x for the first term, and you would have minus a 1/2 sine of 2x plus c. All right, and so you distribute and you end up with 1/2 x minus 1/4 the sine of 2x plus c. So that's one way to do the problem, right? But some of you may say, wait a second, we could do this by integration by parts. Okay, we could rewrite this as the integral of the sine of x times the sine of x dx. You would let u equal sine of x. dv would also be the sine of x. So the derivative du would end up being cosine of x dx. All right, and v, the antiderivative, will be negative cosine of x dx. And then you fill in your little formula that the integral of u dv is equal to uv minus the integral of v du. And I'm going to write it all in. So that would be the integral of sine squared of x dx. That's the original integral, would equal u times v. Okay, so what is u times v? That would be negative sine x cosine of x. All right, so we'll have that in there. And then we'd have minus the integral of v du. So let's get that right. Minus the integral of v du. So we had the zig for the uv minus the integral of the zag. Oh, and there's a negative in there, so that becomes plus cosine squared of x dx. All right. Now, trig identity, we have a sine squared over here on the left, and we have a cosine squared on the right. Let's keep the left the same because that was the original problem. But if I rewrite this on the right-hand side as plus the integral of 1 minus sine squared of x dx, I can then say, I have the integral of sine squared of x dx is equal to negative sine x cosine x, plus I have 1, so that antiderivative is just going to be x. And then I'm going to have left minus the integral of sine squared of x dx. And we saw this before. We have a double iteration. It's a plus on the right and a negative on the left. So if I were to add the integral of sine squared x dx to both sides, I would have twice the integral of sine squared of x dx is equal to negative sine x cosine x plus x, which means, let's keep on going, that, hide the keyboard, the integral of sine squared of x dx is negative 1/2 sine x cosine x plus 1/2 x plus c. Now it looks like we have two different answers. What I want to point out is these are actually the same answer. Okay, so 1/2 x and 1/2 x agree nicely, plus c and plus c agree nicely, obviously, but I have a 1/4 sine of 2x here, negative minus 1/4, and I have a 1/2 sine x cosine x here. Well, you had a trig identity that you may have forgotten about since your sophomore year, where the sine of 2x could have been written as twice the sine of x times the cosine of x. So if we substitute that identity into the left hand, so if we substitute that right here, we end up with an answer of 1/2 x minus, when we put 2 in there, we'll have a 1/2 sine x cosine x plus c. And now we can see that the two answers are the same. All right. So which way was the better way of doing this? I would probably say this is the easier way of doing it. They're both correct ways of doing it. So you can choose whichever one gets you to the answer faster, or sometimes it's just which one do you think of first as you start doing the problem. But you do have to be careful with trigonometric things, because often answers that are correct, you can have multiple correct answers that look different, but they actually are the same because of some of those important trig identities you've had in the past. So I hope that was fun to see. It is also kind of reaffirming that two different independent methods give the same answer. So they're probably, if they're going to agree, it's likely that they're both right, not both wrong. It'd be hard to have both of them be wrong and arrive at the same point in the end.